Assalamu alaikum and welcome to Mathcast with the topic of differentiation, and this is going to be the second part for past papers question. So let's just start the work. The first question that I have chosen is from Summer 21, paper 1, variant 1, and it's question number 11th in the paper. So it says that the equation of a curve is y equals 2 square root of 3x plus 4 and a minus x. And part A says find the equation of the normal to the curve at the point 4, 4, giving your answer in the form y equals mx plus c. So we need to have the normal equation of the normal to the curve. For this purpose, I should be having the gradient of the normal as well as the coordinates at which this normal passes on the curve, and this coordinate is given as 4 and 4. So if the curve equation is y equals 2 times 3x plus 4 to the power 1 by 2 and a minus x, I should be getting the first derivative dy by dx to have the equation of the normal. So let's get the first derivative. For the first derivative, it becomes 2 times 1 by 2, 3x plus 4 to the power 1 by 2 minus 1. And then it should be the differential of 3x plus 4, the chain rule, and the differential of minus x, which becomes a negative 1. So solving it further, I can see that it's the 2 which gets simplified, and I will here be left with 3x plus 4 to the power negative 1 by 2, half minus 1, 1 by 2 minus 1 is a negative 1 by 2, which when taken to the denominator becomes a positive 1 by 2. And the differential for 3x minus 4 is a 3, and then I should be having this negative 1. So this means that the gradient of the tangent when the x value is a 4, that should be equal to 1 over 3 times 4 plus 4 to the power 1 by 2 times 3 and a minus 1. Solving it further, 3 times 4 is a 12, 12 plus 4 is a 16, and square root of 16 is a 4. So the gradient of the tangent becomes 3 divided by 4 and a negative 1, or simplifying it, I should say it's the gradient which equals negative 1 by 4. So this is the gradient of the tangent, and we have been asked to get the equation of the normal, for which we need the gradient of the normal. Therefore, we know that the gradient of the normal shall be the negative inverse of negative 1 by 4. So that should be equal to a positive 4 here. So to get the equation of the normal, the gradient here is a positive 4. The points were given as 4 comma 4. Therefore, I can say it's y minus y1, which is y minus 4, that equals the gradient 4 times x minus 4. Simplifying it further, it's y, which is equals to 4x minus 16, and then this negative 4 taken on the right side becomes a positive 4. So I can say that the equation of the normal is y equals 4x minus 12. So this is how this question then shall be solved. Let's do the second part of the question. Find the coordinates of the stationary points. Coordinates of the stationary point, and we know at the stationary point our dy by dx, it needs to be 0. We already had the dy by dx, the first differential, which was 3 over 3x plus 4 to the power 1 by 2 and a minus 1. I will be substituting this gradient to 0. And if I substitute this 0, I can take this negative 1 on the left side. So this becomes 1, which equals 3 over 3x plus 4 to the power 1 by 2. Solving it further, this becomes 3x plus 4 to the power 1 by 2. I've taken this on the other side, on the left side, multiplied it by 1, giving me a 1 by 2, which equals 3. To eliminate this 1 by 2, I have squared both the sides. Therefore, it's 3x plus 4, which is equals to 3 square, that is a 9. Solving it further, it's 9 minus 4, giving me a 5, or I can say the x coordinate of the stationary point where the gradient is a 0 is a 5 by 3 here. So x coordinate here is a 5 by 3. To get the y coordinate, I shall be substituting this x in the curve equation, which was y equals 2 times 3x plus 4 to the power 1 by 2 and a minus x. X was equal to a 5 by 3. So if I substitute this 5 by 3 here, I should say it's y equals 2 times 3 times 5 by 3 and a plus 4 to the power 1 by 2 and negative 5 by 3. This 3 gets simplified. 5 plus 4 is a 9 and square root of 9 shall be a 3. So I should simply say that this equation shall be 2 times 3 minus 5 by 3, and then simplifying it or taking the LCM, I have just balanced it in the numerator and denominator by 3, and I can say it's 3 times 2 times 3, which is an 18, and it's 18 minus 5 divided by 3, giving me a 13 by 3. So the y coordinate here becomes a 13 by 3, and the stationary point then is a 5 by 3 and a 13 by 3. This is what the question has asked us for. Find the coordinates of the stationary point. Gradient then was equal to 0. So it was a simple question, and we have done it very easily. Let's move to part C. Part C says determine the nature of the stationary point. So for the nature of the stationary point, obviously I shall be having the second derivative. We did have the first derivative. It was dy by dx, which was equal to 3 times 3x plus 4 to the power 1 by 2 minus 1. So I can just take this to the numerator and have the power as a negative 1 by 2. Second derivative then becomes 3 times negative 1 by 2 times 3x plus 4 to the power negative 1 by 2 and a negative 1, which shall then give me a negative 3 by 2 here. So it should be a negative 3 by 2. So negative 3 by 2, and then the differential of 3x plus 4. Differential of 3x plus 4, that should be a 3. So I am left with the second derivative, which shall be negative 3 by 2 times 3x plus 4 to the power negative 3 by 2 times 3. Negative 1 obviously gets eliminated. So here I can say that the second derivative is negative 9 divided by 2 times 3x plus 4 to the power 3 by 2. So if I substitute these values, I can see that my second derivative comes out to be negative 9 divided by 2 times 3 times x substituted as a 5 by 3 plus 4 to the power 3 by 2. Solving it further, it comes out to be a negative answer, which is a negative 1 by 6, which is less than 0. And I can say and see that the nature for all the values of the second derivative to be less than 0 always have a maximum nature. So the nature of this stationary point then needs to be a maximum. So the second question has been taken from February-March 2022, and it's paper 1 variant 2, question 11th in the paper. And it says it is given that a curve has equation y equals k times 3x minus k to the power minus 1 plus 3x, where k is a constant. So find in terms of k the values of x at which there is a stationary point. So again, there is a stationary point. That means our dy by dx needs to be a 0. So this is the hint that we should be having from this statement. And we need to find x in terms of k. So this is another hint that we should be having here. So y is given as k times 3x minus k to the power minus 1 and plus 3x. Getting the first derivative, it's dy by dx, which shall be equal to k times negative 1 and 3x minus k to the power minus 1 times the differential of the function 3x minus k, which shall be equal to a 3. So it's multiplied by 3, and then I have the second term, which is a positive 3x. The differential of positive 3x is just a 3 then. So the first differential, which shall be equal to 0, as it's the stationary point, as it is the stationary point, the first derivative, it should be equal to 0. This then shall be equal to k times minus 1 times 3, which is a negative 3k, divided by 3x minus k the whole square, and then a plus 3. So solving it further, it's 3k over 3x minus k the whole square equals 3. The 3 gets simplified, and then I can say it's k, which is equals to 3x minus k to the power square. To eliminate the square, I shall be taking the square root on both the sides, so that I will be left with a plus minus square root of k, which shall be equal to 3x minus k. So I can see here that the question has asked for values of x. So this is how I shall be getting the values of x over here with respect to the positive and the negative sign. So solving further, I can say that this 3x can be equal to a plus minus square root of k and then a positive k taken on the left side, or x then shall be equal to k plus minus square root of k divided by 3. So these are going to be the values of x for the stationary point. Let's do part B. The function f has a stationary value at x is equals to a. So it's the function x with the stationary value meaning the first derivative or f prime x. This should be equal to 0 when x is a. And this is defined for f of x which equals 4 times 3x minus 4 to the power minus 1 plus 3x over here. So this is also defined for x to be greater or equal to 3 by 2. So find the values of A and find the value of A and determine the nature of the stationary point or the stationary value. So here what I can see is that in the first part our f of x or the equation of y was given as k times 3x minus k to the power minus 1 plus 3x. And just in place of k, what I can see is that 4 has been substituted. Therefore, if our fx is now 4 times 3x minus 4 to the power minus 1 plus 3x, it's just a 3-mark question. So I should be saving my time here. So I already have my f prime x from part 1. From part 1, I already have my f prime x or the first derivative, which was a negative 3k over 3 k 3x minus k the whole square and a positive 3. So just in place of k, I shall be substituting a 4 here. So doing that, our f prime x becomes negative 3 times 4 divided by 3x minus 4 the whole square and a positive 3. That means our f prime x is a negative 12 over 3x minus 4 the whole square and a positive 3 here. So according to the question, stationary value is when x is equals to a, meaning the first derivative shall be equal to 0. F prime x shall be equal to 0 for x is equals to a. So x was already calculated from part A, the stationary x value as k plus minus square root of k divided by 3. So x is an a and k value, we have already said that k by comparison is a 4. So I have substituted x as a, k as a 4, and then a shall be equal to 4 plus minus square root of 4 divided by 3, or I can say a is equal to 4 plus minus 2 divided by 3. 4 plus 2 is a 6 divided by 3 and 4 minus 2 is a 2 by 3. So a then shall be equal to a 2 and a 2 by 3 here. They have also given us this condition which says that x needs to be greater or equal to a 3 by 2 or a 1.5. That means this value of a, which is a 2 by 3, shall not be taken into account, and I can just say that a here should be equal to a 2. They have also asked us for the value of a, meaning there should be just one value of a here, which in this case comes out to be a 2. After that, they are saying, after finding the value of a, they are saying determine the nature of the stationary value also. So obviously for the nature, I should be going for the second derivative. Our f prime x was from here was equal to a negative 12 3x minus 4 to the power negative 2 and then a plus 3. So second derivative then shall be equal to negative 2 times negative 2 and 3x minus 4 to the power negative 2 negative 1, and this then should get multiplied by the derivative of 3x minus 4, which is a 3, and then the positive 3 gets eliminated. So here our second derivative becomes a 72. 12 times 2, 24 times 3, this becomes a 72 divided by 3x minus 4 to the power positive 3. So When x is a 2, I can substitute x as a 2. 3 times 2 gives me a 6. So 6 minus 4 to the power cube. So it's 72 divided by 6 minus 4, which is a 2, and 2 cube is an 8. So it's 72 divided by 8, and that's a 9, which is greater than 0. Even from here, I could see that the second derivative with the substitution of x as 2, here with the substitution of x as a 2, I can see that this value is becoming a positive value. That means it has to have a nature which is going to be a minimum here. 9, so therefore as 9 comes out to be greater than 0, so the nature here shall be a minimum nature. The third part of the question, it says that the function g is defined by g of x, which equals negative 3x plus 1 to the power minus 1 plus 3x for x to be greater or equal to 0. For x to be greater or equal to 0. So determine, making your reasoning clear, whether g is an increasing, a decreasing function, or neither. So again, it's a 2-mark question, so not a lot of working should be required here. What I can see is that this gx, if compared with the f of x, which was given in part A, f of x was k times 3x minus k to the power minus 1 plus 3x. And if I compare it here, g of x is negative 3x minus and then minus 1 to the power negative 1. So what I can see here is that my k value here should be a negative 1. So if my k value is a negative 1, our g prime x, that should be equal to a negative times negative 1, 3x plus 1 to the power minus 2, minus 1, that gives me a minus 2. The derivative of 3x minus 3x plus 1 shall be a 3, and then it should be a plus 3 from here. So I can see that it's 3 divided by 3x plus 1 the whole square and a plus 3. And here, because of this square, I can see that for all x values which are greater or equal to 0, x needs to be a positive, and also because of the square, the value here needs to be a positive, because all quadratic values are always positive. So positive plus positive, it's going to be a positive answer, which means it's going to be the derivative here is going to be greater than 0, meaning positive. Therefore, the function gx needs to be an increasing function. So this is how then this question needs to be done. Let's move to the last question, which I have chosen from Winter 2019, paper 1, variant 2, and it's question number 5 in the paper. So it says that the diagram shows a solid cone which has a slant height 15 centimeters and a vertical height which is 8 centimeters, and we have to show that the volume v centimeter cube of the cone is given by v, which equals 1 by 3 pi 225 h minus h cube. And also they have given us the volume of the cone with radius r and the vertical height h as 1 by 3 pi r square h. So I will be using Pythagoras theorem here, and with respect to the Pythagoras theorem, I have this right angled triangle. So I have this vertical height h here, the base, which is the radius, and then the slant or the hypotenuse, which is 15. Applying the Pythagoras theorem, h square 15 square equals the perpendicular square, which in this case is h square, plus the base square, which is plus r square here. I need everything in terms of h. So from here I can say it's the r square, which shall be equal to 225. 15 square is a 225 minus h square. Or if I take the square root, I can say that the radius has to be a square root of 225 minus h square. Obviously, I will be ignoring the negative sign here because the radius can never be a negative. So in the volume of the cone, it's 1 by 3 pi r square h. So volume then shall be equal to 1 by 3 pi r square 225 minus h square substituted and then multiplied by h. So the volume becomes 1 by 3 pi 225 h minus h cube, and this is what the question has asked us to show, which is 1 by 3 pi 225 h minus h cube, and this is shown here. Let's move to the next part of the question. Given that h can vary, find the value of h for which v has a stationary value. So v has a stationary value means if we have v in terms of h, then dv by dh should be equal to 0. So we need to find this value of h and then determine, showing all necessary working, the nature of the stationary value also. So please always underline the keyword so that you do not miss the second statement here. So first, it's to get the value of h for the stationary value of the volume. So I have v, which is 1 by 3 pi times 225 h minus h cube. dv by dh then shall be equal to 1 by 3 pi 225 h. Differential is a 225 and h cube becomes a minus 3h square. Stationary value, this becomes a 0. The first derivative becomes a 0, meaning pi by 3 that gets eliminated because of the 0 value here. 225 minus 3h square shall be equal to a 0 then. Or I can say it's 3h square which equals 225, or h square equals 225 divided by 3 which equals a 75, or h square is a 75. Then h then shall be equal to a plus minus, again ignoring the negative sign because of the height. It should be a positive square root of 75, or I can say that my h here is 5 square root of 3 centimeters. So I'm done with the first part, which said find the value of h for which v has the stationary value. Second part, determine, showing all necessary working, the nature of the stationary. So nature means I should be getting for the second derivative. So if my first derivative was 1 by 3 pi 225 minus 3h square, then from here the second derivative becomes pi by 3. 225 gets eliminated. Minus 3h square means it's a negative 6. 3 times 2 is a 6, and then h. So this then becomes a negative 2 pi h, which is less than 0. So I can see even if I substitute this h as a 5 square root of 3, it should be giving me a negative answer as it is less than 0. I know from here also that the nature has to be a maximum. But let's substitute h as a 5 square root of 3. Doing that, it becomes a negative 10 pi square root of 3, which is less than 0. And the nature here needs to be a maximum nature. That means the volume needs to be a maximum volume here. So this is how differentiation gets done. And I hope the topic is clear to everyone. I shall be closing now the differentiation topic. And in the next video, I shall be meeting you with integration. So till then, take care and bye bye.